I don't know what I was most nervous about, giving the talk in front of all of you, my colleagues, or your introduction, but just to finish that off, this is my midlife crisis. Right? I couldn't afford a sports car, so I grew my hair out. So thank you all for coming out, and I hope, as Igor says, that it's not going to be a boring talk. I'm going to talk to you about the work that my students and I have been doing over the last 5 to 10 years or so, trying to understand boredom and the consequences that might be attendant to experiencing the state more prominently. So I should start with a definition of what I mean by boredom, and perhaps foolishly, I turn to existential philosophy. So the quote here from Schopenhauer is that the two enemies of human happiness are both pain and boredom. And that captures a couple of things about boredom that I think are important. One, it's a negatively valenced state. We don't like it. I don't think I've met anybody that says that they enjoy being bored. But the other thing that this evokes for me is that it's a state that we want to redress. We need to do something about it. And I think that's important to point out because often when I talk to people about boredom, the image that comes to mind is that of the couch potato. And to me, that's apathy. That's not boredom. Boredom is absolutely a motivational state. It's a call to action, and you'll hear me use that phrase a couple of times. Kierkegaard is perhaps a little bit more melodramatic about it in claiming that boredom is the root of all evil. I don't think I'd necessarily agree with that, but we do know that being prone to experiencing boredom, so experiencing it more frequently and more intensely, does have a whole range of attendant problems with it. So it's associated with increased rates of depression and anxiety. It's associated with increased rates of aggression. People who are highly boredom prone have higher rates of drug and alcohol addiction. There's some hint that they also have problems with gambling. They're increased risk takers. They're more impulsive than the rest of us. So there is certainly a notion that there's not a lot that you can associate with being boredom prone that you would claim would be positive. There's another sort of anecdote that came across my radar a while ago. A guy called Chris Lane, who's an Australian baseball player, playing college ball in the United States, was shot dead one morning by 3 teenagers. And when the police asked them, well, why'd you do it? They said, well, we were hanging around, we had nothing to do, we were bored, so we decided to kill somebody. Not to suggest it's a bit hyperbolic that boredom is going to lead to such extreme acts of aggression, but it does push people to act in some way, and the highly boredom prone might do so in fairly maladaptive ways. And then this is my favourite quote, not least of which because I'm atheist, I guess. But Nietzsche says that the boredom of God on the 7th day of creation would be a subject for a great poet. Now, God might well be entitled to sit back in her lazy chair on the 7th day and say, look at all this magnificent universe that I created and all the magnificent things in it. But even for God, on that 7th day, the next thing that will happen is she'll have to say, and now what? What am I going to do next? And that couches boredom for me in the context of goal pursuit. That boredom is a push to action, a push to explore your environment for avenues to engage, for avenues to be engaged. And I think that that's a really important sort of part of it. And then the last sort of association I'll make here is a metaphor with pain. So if I suggest that boredom is this kind of negatively valent state, it's motivational, so we want to redress it, we want to do something to alleviate the boredom, and it's this call to action. So pain is not there. The function of pain is not to cause hurt. The function of pain is not to make us feel pain, but it's to make us act. So the cherub with the impossibly small feet here in this picture is going to feel pain from the fire and presumably retract his foot from the flame. And that's the purpose of pain. And I would suggest to you that's also the purpose or the function of boredom. It's a call to action. What you're doing now is not satisfying in some way or another. You're not able to deploy your talents and skills to full effect, and you need to do something else. Or whatever it is that you're doing is not meaningful to you, you need to do something else. So boredom is that sort of call to action. And if I think about it as a call to action, then I might characterise boredom as a fairly high arousal kind of state. Let me play you this genuinely engaging video while I talk about this. So you're motivated to engage in something, and so you need to address this sort of motivational need. And if you're failing to address that motivational need, then it'll be accompanied with a sense of restlessness, a sense of agitation. And then that would make me categorise boredom as a high arousal state. But it turns out that in the literature, this is one of the more long-standing debates in the boredom literature over the past 80 to 100 years, such as it is. And it turns out that about 50% of the literature on boredom would suggest it's a low arousal state, and 50% would suggest it's a high arousal state. So one of the very first things that we wanted to do was to look at that particular question. Should we properly characterize this state of boredom as a high arousal state? So my graduate student at the time, Colleen Merrifield, who was in the clinical area, and together with a lot of help from David Moskovich and his lab, put together a study to look at whether or not boredom could be characterized as a high or low arousal state. And what we did is we did some video mood inductions. She created this video of two guys hanging laundry. And it gets a chuckle. Every time you put it up there, it gets a chuckle. I'm not quite sure why. I'd be interested in finding out whether or not people think you cannot be serious, that you want me to watch a video of two guys doing a bad job of hanging laundry. Nevertheless, the laughter subsides after about 10 or 15 seconds and people get thoroughly bored. Doesn't take long, about a minute, and your boredom ratings, your self-reported ratings of boredom are pretty high. So we had different groups induced to experience boredom with our video or to induce sadness. So we had them watch a clip from a 1976 movie, The Champ, where a young boy is crying over his father's impending deathbed. And we had them another group watch a clip from BBC's Planet Earth, which we hoped would be a neutral mood induction, but it turned out to be engaging. People were quite interested in Planet Earth. And we measured heart rate and skin conductance levels and also cortisol. And what we found was that relative to the state of sadness, heart rate rose in the boredom mood induction and skin conductance levels fell. If this was just an agitating state, you might expect both of those measures to rise together in lockstep. What this pattern is known as is a directional fractionation, where the heart rate increases and skin conductance decreases. And where you see this pattern of psychophysical responses is in a disengaged attentional state. So when we tend to focus on a task and where our focus is quite effective on a task, heart rate tends to drop and skin conductance rises. When we lack focus on a task, heart rate rises and skin conductance dips. This has been partially replicated by another lab, Jang and colleagues. They didn't replicate the heart rate findings, but the moods they were comparing were pain and surprise, so you might expect heart rate to be quite high in those. But they did show that the skin conductance dropped as in the boredom mood induction. We did also sort of find that relative to sadness that cortisol levels were higher following that boredom mood induction. These are not cortisol levels that are through the roof. They're not at the sort of magnitude that you might expect to see in something like a social anxiety induction, but they're nevertheless higher than that sadness induction. So these results led us to suggest that the state of boredom is a state of being disengaged from your environment or the task at hand, but that it's also associated with some sense of stress, some sort of feeling of agitation. And if I'd stopped there, then I might have said, we've solved the problem here. Boredom should be characterised as a high arousal state. But more recently, with Dan Smilek and an honours student of ours, we had a look at self-reports of boredom and associated sort of constructs that I'll get to in a second. We measured eye movements as people read various passages. One passage from Harry Potter that we imagined would be engaging and interesting, and one passage from the stimulating book, The Elements of the Nature and Properties of Soils. And unless you're a terroirist, look it up, you probably wouldn't be interested too much in what that book had to say. We measured eye movements because we were interested in things like blink rate, which Dan and his colleagues have shown are associated with epochs of inattention. And we also wanted to measure pupil dilation to look at that as a psychophysical metric of arousal. I'm not going to talk about those, unsurprisingly, because they didn't show a hell of a lot. We counterbalanced the order in which the stories were read. And what you're looking at here are these self-report ratings periodically during a 20-minute period of reading for boredom. The interesting story presented in black and the boring story in white. And you can see, just by an eyeball test there, that the manipulation worked. People were more bored when they read about soils than when they read Harry Potter. And you can see there's also an order effect. If I read the boring story second, my boredom ratings go through the roof. But the really important thing to state is that if you read the book about soils, then you're going to be bored. And then we asked them to give us their self-reported ratings of restlessness, some sort of metric of how you feel, whether or not you feel agitated or restless as you're engaging in these reading tasks. And again, restlessness was higher for the boring story than it was for the interesting story. There is a significant rise in restlessness with time. I think this generation doesn't like to sit and read for 20 minutes. And the restlessness ratings were the worst when you read the boring story second. So again, if I stop there, I might sort of claim that boredom is an agitated state, boredom is a high arousal state. But we also asked them how sleepy they were. And it turns out that at the same time that our subjects were reporting increasing rates of restlessness while they were reading about soil, they were also reporting increased rates of sleepiness. It feels counterintuitive, at least it does to me, that you can say, I'm restless, but I really want to take a nap right now. What it suggests to me is that you probably shouldn't characterise boredom as either a high or a low arousal state, but dynamically as an oscillation between the two. And this is something that I'd like to pursue in further sort of research to try and understand the dynamics of the state. Does it begin as a low arousal signature, suggesting that you're not engaged by whatever it is you're doing now, and then rise to a high arousal state as that persistent sort of under-arousal continues? I don't really have answers for you, but I think that this, at least on the level of self-reports, suggests that it's both a high and a low arousal sort of state. This gift comes to me from my graduate student, Andrew Struck. And God knows what's going on in this guy's mind. He's standing on the side of the street, presumably waiting for somebody to come and pick him up. The waiting is killing him. It's taking too long, so he's just going to tip that bin over. Now, I might hope that most of us in the room here would be able to exercise a certain amount of self-control and not tip that bin over. But this is the kind of thing that sort of fits well with the definition I've already given you of boredom, that it's a call to action. Whatever you're doing now is not really satisfying for you. Do something else. Fuck it, I'll tip the bin over. Presumably, again, most of us would avoid doing that, but this guy can't manage it. In time and again, in all of the sort of mass testing samples that we've looked at, and we've looked at many of them, this is just one example, we do show this strong negative correlation between self-control and boredom proneness. So the higher boredom-prone individuals tend to exhibit lower levels of self-control. And it might, this will come up again in later parts of the talk, it might be that their capacity to respond adaptively to what is the state signal of boredom is disrupted in some way. They're not able to sort of channel that need that boredom signals to become engaged into adaptive sort of responses. And if boredom is related to self-control, then we might expect that rates of boredom change as we age. Presumably, as we get older, we can develop higher levels or higher capacity for self-control. The data that you're looking at here comes from Giambra and colleagues in 1992, and it shows indeed that from about the late teens, and they measured this right through until the 60s and 70s, boredom tends to drop as we age. There's potentially lots of different reasons. The one I want to convince you of is that at least in that early epoch, from the late teenage years to the early 20s, we're having the final stage of frontal maturation come online. Those late stages of maturation where executive control and executive skills are coming online will mean that you'll be able to exhibit a higher level of self-control, and in doing so, experience boredom a lot less. There's an interesting sort of part in this graph too. There's an uptick, a slight but significant uptick in boredom, particularly in women, towards the later stages of life. And the Garner paper that I referenced there has just recently replicated that finding as well. Why people get bored later in life is probably a completely different sort of story about social networks and connectedness that I'm not going to get into here, but we'll be happy to talk about. So this is just from one of our samples, showing you that in those under 30, the boredom ratings are quite a bit higher than they are in individuals who are under 30 years of age. And on the right-hand side, you're seeing that same data plotted as a function of self-control. As we age, we garner higher levels or higher capacities of self-control, and as a consequence, we experience boredom less. And this brings me to the thing that actually got me started in boredom research in the first place. So as a clinical neuropsychologist in Australia, I examined between about 15 and 20 individuals, all of them young males, who had experienced traumatic brain injuries. And as part of the history-taking interview for those individuals, I would ask them, are you more bored now than you were before your injury? And to a number, they leapt out of their seat to say yes. And I describe it in that way in particular because they were excited that somebody had bothered to ask them about this experience of boredom post-injury. It was important and consequential for their recovery after a traumatic brain injury. And the kinds of injuries that I'm talking about here are injuries that affect the frontal cortex, and the sine qua non of that traumatic brain injury consequences is dysexecutive syndrome, problems with self-control, problems with impulse control, and these kinds of things that we know are associated with boredom proneness. All of that was anecdotal until with my graduate student, Yulia Isacescu, that we actually measured this, and so you can see in controls from our mass testing group. And I'm always surprised every year when we collect mass testing at just the sheer number of individuals who have had at least one concussion. And those guys have a slightly higher level of boredom proneness in their ratings. And then in a small, relatively small group of people with moderate to severe traumatic brain injury, we showed quite a dramatic increase in boredom ratings. So there really is this fairly strong link between your capacity for self-regulation and self-control and boredom proneness. And I'll just say one last thing about boredom and age, and this comes from data from Tina Willoughby, who's at Brock University. She actually did her PhD here, and I gave a talk at Brock almost a year ago now, and she sort of dumped this huge and enormous and rich and wonderful data set in our lap and said, play. This is about 2,000 8 to 15-year-olds that she has an enormous amount of survey data on, that she's going to be collecting longitudinal data from. This is just one snapshot. And in amongst all of that survey data are questions of boredom. And we would have hypothesised, based largely on the Spaeth paper in 2015, that in this age range, boredom would function as a positive age would function as a positive predictor of boredom, so that as you get a bit older, you'll experience a little bit more boredom. And the reason for that is that this is the age group at which those executive functions I've talked about are just starting to come online. And yet, they're living a constrained life. Whether they're constrained by parental rules or whether they're constrained by the school environment and the requirements that that environment entails, they're getting these new skills, developing these new skills, but not fully able to deploy them. And so that would be why we would have thought that boredom would increase with age in this age range. And you can see it's not a huge effect, but it's there nonetheless. One of the interesting things I'm happy to talk about later on is that this relationship in this age range between boredom and age is almost fully mediated by self-esteem and tech use. So how much time you spend on social media. And I think there's some interesting stuff there to be had. So I've characterised boredom as this motivational state. It's a call to action, and it's associated with self-control. So those who have self-control don't experience much boredom. Those who don't have much self-control do experience boredom. But self-control is a fairly broad kind of concept and not one that gives us a sort of the capacity to look at specific ideas of self-regulation. So with Abby Scholar and my students, Jatisha Mugon and Andrew Struck, we've started to have a look at this using these concepts of regulatory mode theory that come to us from social psychology. So if I say something wrong about those theories to all the social psychologists in the room, please don't hang me now, hang me later. At the reception where I can have beer to deal with the embarrassment of it all. So this comes from Ari Kruglanski's colleagues, where they talk about different modes of essentially goal pursuit. So the regulatory mode label that they call the locomotor is a kind of mode of goal pursuit where the individual likes to just move from one action state to the next. They like to get on with things, colloquially labelled the just do it mode. And in those individuals who are high in adopting a locomotion regulatory mode, they tend not to experience boredom. It tends to act as a prophylactic against boredom, which makes a little bit of sense because these guys aren't wondering what they want to do, they're just doing it. The other regulatory mode, the assessment regulatory mode, sometimes referred to as a do the right thing mode of goal pursuit, is instead characterised by people who want to evaluate the available options for action and engagement to make sure that they do the right thing, make sure that they don't make too many mistakes. And for individuals who adopt this regulatory mode, they tend to be more prone to boredom. And we've characterised this, and we stole this phrase from my colleague John Eastwood, who also did his PhD here. We've characterised this as a failure to launch. And I think this is really important in trying to understand boredom proneness. People who are high in boredom proneness register and recognise the signal of state boredom. They recognise that right now, in the moment, I'm disengaged. But they fail to heed that signal adaptively. They fail to launch into meaningful activities that satisfy that desire to be engaged. It's a bit of a conundrum and a paradox. There are many possible reasons for why a person who's high in boredom proneness might fail to launch. And my students are sort of currently pursuing a number of those. In the literature, people like Wijnand van Tilburg and his colleagues have couched this problem in terms of seeking meaning or meaning making. So the higher boredom-prone individual lacks a sense of purpose or lacks a sense of life meaning. People have also focused a lot on monotony, as that monotonous circumstances prompt this sense of boredom. But I don't think those two components are the only components that will lead to the experience of boredom, or the only components that are critical for those who are highly boredom prone and experience it more intensely and frequently. So we are interested in things like skill, challenge, fit. We're interested in a sense of autonomy. So when you feel like you have a greater sense of autonomy, you're less likely to be bored. And the one thing that I'm going to talk to you about now is we're also interested in effort regulation. So a highly boredom-prone people just less willing to put the effort in to engage. And the picture I have up here is for all of those parents in the room that would be familiar with that anecdote where your child comes to you and they say, "I'm bored." What they're actually saying to you is more than that. They're saying, "I'm bored, fix it for me." They want you to do something about it. And as the obliging parent that I know that I've been in the past when my kids have said that, you make suggestions. Go ride your bike. Go play with your brother. Go shoot some hoops outside. Go read a book. God forbid, go play video games. Whatever it is that you say. And the child summarily discounts all of those suggestions you have to fix their ennui. So they're bored, they recognise the feeling, they recognise they want something to do, and things that you suggest to them that you know have worked to have them engaged in the past are just dismissed, as though they want the world to come to them and they want it to be easy. They don't want to exert any effort. So we had a look at this. We wanted to see, well, is that the case? Do highly boredom-prone people are they just less willing to exert effort? We borrowed a task from Deanna Barch and Treadway and colleagues. That's an effort discounting task. So on this task, on every trial, people are given two choices, an easy task or a hard task. Both tasks are button presses, and you just make them hard or easy by whether or not you use your index finger, that's the easy, or your pinky finger, that's the hard, and how many button presses you have to do in a certain period of time. Fewer button presses in a smaller amount of time for the easy task. The key here is the easy task is associated with a low amount of monetary reward, and the hard task will give you more money. And then the other addition is that on each trial, you are told that there is a different probability of winning, either 12, 50, or 88% chance of winning. What we want to see here is what's the level at which people discount doing the hard task and just choose the easy task? When do they opt out of doing something difficult? So they choose a task, easy or hard, they start their button press, there's a health bar that shows their progress, they either get feedback saying they completed it or they failed, and then after that feedback they're told whether or not they won and how much money they won. So what you're looking at here is data from about 100 undergraduate students doing this task. On the left is the probability of winning. I don't have the 12% probability because that's a pretty flat line. And you can see as the probability of the chance of winning the reward on any given trial increases, so does your willingness to do the hard task. And that is fairly understandable. But at either end of the spectrum of boredom proneness, people are less willing to do the hard task at both levels of probability of winning. I'm not entirely sure what's going on at the low level of boredom proneness. Is this apathy or is this something else? That's something I'd like to investigate. But at both ends, the high and the low end of boredom proneness, people are less willing to do the hard task. And the same is true when you look at the reward values. So the higher the reward value, the more willing people are to do the hard task, which is something that you'd probably expect. But at the high end of boredom proneness, regardless of that reward level, people are less willing to do the hard task. We're in the process of replicating this, which I think is important to do. We want to make sure that this is a fairly robust kind of finding, but at least gives some idea that for the highly boredom prone, they want things to be a little bit easier to do. So again, I've cast boredom proneness as a call to action. I've suggested that the highly boredom prone people, for a variety of reasons, including problems with effort regulation, fail to launch. But I want to have some sort of metric or some sort of association in a task that sort of shows me that they really do behave differently than high and low boredom prone people behave differently somewhat. And what we did next sort of came serendipitously via a meeting with my colleague Marla Sokolovsky, who's here today from the University of Toronto. I gave a talk at Western University where Marla was the keynote speaker. And so I gave my talk just before hers. I sat down in the audience and she started giving her talk on Drosophila melanogaster, the fruit fly. And she was talking about different phenotypes on the fruit fly that she labelled the rover and the sitter. And I'll talk to you about those in a little bit more detail in a second. And halfway through her talk, she says, I've been doing some work with Tori Higgins looking at whether or not this distinction between rover and sitter is conserved in humans using this metric of assessment and locomotion. And I had an oh shit moment. I thought, that's really good. Maybe I could get together with Marla and translate some of what we've done with assessment and locomotion and see whether or not there's actually a genetic basis to some of the differences we see in boredom proneness. It's a lesson in sort of serendipity and the value of having a beer after a talk to get something going. So we chose then to look at foraging and its association with these regulatory modes that I've already talked to you about, and also the association with boredom proneness, and then to look at the genetic associations with that. Why foraging? Well, in part because Marla's work in the fruit fly is about the foraging gene. So it makes sense to start to look at foraging behaviours, and a lot of that early work in Drosophila looks at different metrics of foraging behaviour. But one of the other reasons why I think it was a good task for us to look at with respect to boredom proneness is this notion that boredom signals the need to explore and do something else. Foraging is an exploratory behaviour. Foraging is a behaviour that you engage in to explore your current environment for resources, in this instance food. And it actually involves balancing two behaviours of exploration and exploitation. So if any of you have ever been to a pick-your-own-berry farm, you stand in front of a bush of blueberries and you do not denude that bush till it's completely bare of any berries. At some point, you decide it's not worth the effort to stay in this location and exploit those resources, and instead you move on and explore for a more richer bounty in a different berry bush. So I thought that this is an ideal task that perhaps those who adopt assessment or locomotion regulatory modes, those who are high or low in boredom proneness, might demonstrate distinct behavioural patterns on a task of this kind that warrants, that pushes you to a decision to explore in your environment. So what are these fruit fly distinctions that Marla and her colleagues make? This comes from data from the Houston paper in 2017, and these are adult fruit flies in a dish that has 4 food sources. Marla, correct me if I get anything wrong here. And these are heat maps showing the exploratory behaviour to find those food sources in these dishes. On the top 2 rows, you've got rover fruit flies, and on the bottom 2, sitters. If you focus just on the left column in the first instance, you'll see one of the key distinctions between these phenotypes. The rover explores their environment more extensively than does the sitter. You can see that the sitter hugs the boundary of that environment, staying close to local resources in a sense, and not exploring or foraging further afield into the centre of that environment. Now we cast that in terms of a sort of risk tolerance. For an animal in this kind of environment, to go to the centre of that environment entails some amount of risk. So the rover may have a higher risk tolerance level than does the sitter. What you're seeing in the right columns then is the same thing, the heat maps for the rovers and sitters in these environments after 24 hours of food deprivation. And even then, you see that the sitter still hugs the boundary of the environment. This is a circumstance where you'd think the animal might be motivated now to explore more extensively to find the food source, but still the sitter takes that sort of low-risk strategy of hugging the environment, hugging the boundary of the environment. So how are we going to test this in humans? My student Andrew Struck created this fantastic task, pardon me, that we deploy on a touch screen. So it's a fairly large environment, 20,000 by 20,000 pixels, pardon me. And you swipe through that environment on the touch screen and tap on berries as you pick them. It's a great task because I think it's quite a fecund task that you can have many manipulations of this that you could use to look at various kinds of behaviours. You can change the density of the berries in the environment. You can change the goal of the participant in various sorts of ways. I'm just going to show you data here from people foraging through this environment where the berries are uniformly distributed throughout. And we can measure a range of different things in this task. We can measure individual sorts of metrics. What is the path length that they search through that environment? How many berries do they collect? And many other individual metrics besides. Andrew has a whole range of them that you can talk to him about if you like, things like turning angle and so on. Or you can use all of those dependent variables to now create a classification of different types of search paths. And that's ultimately what we ended up doing. So what you're looking at here are individual examples of the 3 groups of search paths that we classified in this task. And below those are heat maps for the individuals in that group. And right away, you see that the largest group that we classified would be what we called a boundary bias group. Everybody in this task starts in the middle of the environment. So you can see for that boundary bias guy, starts in the middle, rapidly finds the edge of the environment, and then works his way around, his or her way around. The other group that was most easily classified, we referred to as systematic. They went back and forth through the environment or up and down through the environment very carefully and systematically. And the final group, which were more difficult to sort of classify, we've just labelled mixed here. So the one example that you're looking at there looks like an individual who's meandering through that search environment quite aimlessly. But a good number of the individuals in this group looked like they were sort of partially systematic and partially boundary biased. And so it was kind of hard to put them in one or either of those sorts of groups. But nevertheless, we have these 3 groups of search behaviours on our foraging task. And those heat maps, actually I've got this sort of a little bit out of order, but those heat maps then and those behaviours in the foraging environment are indeed going to associate with different genotypes on the human ortholog of the foraging gene. Those heat maps are based on our classification of search paths. These heat maps here, Andrew just gave to me the other day, yesterday, I think, and these are based now not on the search paths in the foraging environment, but just on the genotype. So the homozygous A and homozygous C alleles on the human ortholog of the foraging gene, which I'll get to in a little bit more detail in a second, have these search paths that look remarkably like rovers and sitters. More a stronger association between the sitter than the rover. But you can see that those with the A allele, homozygous A allele, tend to hug the boundary of the environment, whereas the homozygous C allele guys tend to sort of explore a little bit more extensively. If we look at variation on the human ortholog of the foraging gene, which is known as PRKG1, and we're looking at a particular single nucleotide polymorphism here. If you're interested, it's RS13499. And you can see, again, that we created a composite score of regulatory mode. So on the top there, negative scores indicate a preference for an assessment regulatory mode. Positive scores indicate a preference for the locomotion regulatory mode. And you can see that the presence of the A allele is predictive of a bias towards assessment. Those same individuals that have a bias towards adopting an assessment regulatory mode also tend to hug the boundary of the environment in our foraging task. So they really are behaving a lot like the fruit fly sitter. We don't have as much to say strongly about the homozygous C allele people, whether or not they look like rovers, but it's something certainly worth following up on. And my postdoc, James Boylan, is going to be trying to replicate this work in the coming months. So I was interested in this regulatory mode and the association between whether or not the sort of phenotypes of the rover and sitter would be conserved in humans, but ultimately I'm also interested in boredom proneness. And here you're seeing data that we're also interested in replicating, looking at boredom proneness and self-control. And again, those individuals that have an assessment regulatory mode preference that hug the boundary of our foraging environment tend to have higher levels of boredom and lower levels of self-control. So it's really interesting sort of data that we're following up on now. We didn't just look at PRKG1. We also looked at a number of other genes and SNPs on genes that we thought would be important for trying to create a profile, if you like, of the highly boredom-prone individual. We looked at SNPs related to norepinephrine, to serotonin. What I'm showing you here is SNPs related to COMT and DAT, or sometimes referred to as DAT1. These are both genes that are going to be important for the regulation of dopamine. And we chose these to look at because dopamine is very heavily involved in the reward networks of the brain and processing of reward, and it may well be that highly boredom-prone individuals just have dysfunctional regulation of that reward network. And here you can see that the homozygous T allele has higher levels of boredom proneness and lower levels of self-control, both on COMT and on the DAT1 SNP that we looked at. Again, this is work. So when Marla and I started this work, we were quite excited by it, and then halfway through, the field changed and decided that they were not as enamored by candidate gene studies of this kind. So we are sort of pushed into somewhat willingly, pushed into a replication of this stuff. So I'm sort of looking forward to seeing whether or not this replicates and what else we might sort of find out about it. The notion, though, that the highly boredom-prone individual might have dysfunctional sort of regulation of dopamine also starts to sort of point to parts of the brain that might be important for the experience of boredom. Medial prefrontal cortex, dorsolateral prefrontal cortex, the ventral striatum, all known to be important and involved in the regulation of reward and the representation of reward, might be good targets to look in to see whether or not there's differential activation in high and low boredom-prone individuals in these parts of the brain. And so that's the thing I'm going to finish off with today. This is work from Martin Ulrich and colleagues. They have 2 studies. I'm just sort of showing you data from one here. They weren't interested in boredom. They were interested in what some might consider to be the opposite of boredom, and that's the state of flow. I don't particularly think that flow is the opposite of boredom. I think it's an opposite of boredom, and we can talk about that if you're interested in more detail. What they had people do was mathematical sums. In some instances, those math sums were facile, just completely easy for the person to do, and that was their boredom condition. This was just going to be monotonous and unchallenging, and so it was going to be boring. In another condition, they had the math sums be beyond the level of competency of the subject. So this was what they called the overload condition, indicated by O's here in this graph. So this was meant to be more representative of frustration. And then in their supposed flow condition, they had individuals performing these math sums that were titrated perfectly to their level of competency and skill. On the left, you see areas that are more active during that flow state, so the left inferior frontal gyrus and the putamen. And on the right, you see areas that are more active during the boredom and overflow states. So this is the medial prefrontal cortex and the left amygdala. Medial prefrontal cortex is interesting to me because this is a major node of what is known as the default mode network. And the default mode network is a network of brain areas that tends to show increased activation when there is no external task for you to be engaged in. And I've characterized boredom as a state of wanting engagement but failing to be engaged, so that perhaps for the highly boredom-prone individual, there's plenty of stuff out there for you to do, but none of it that you want to do. And so perhaps you'd see some increase in activity in those brain areas that are activated during the default mode. This is data from Delmas and Whitman more recently in 2017. They had people perform a range of different tasks, one that they characterized as a difficult search task, one that they characterized as being boring, and another one that was just a preference kind of task. And at the end of those tasks, they asked people, how much money would you be willing to pay for a music download? And what you're showing in the top left there is that when you've done the boring task, you're willing to shell out more money for music. It's like, get me out of here, give me something, give me anything to do away with that boring task that I just had to do. And it turns out that your willingness to pay money for music after you've been bored is also associated with activity in a particular part of the brain known as the anterior insular cortex. And the insular cortex, I think, is really interesting. Pops up in just about every neuroimaging study ever done, and people tend to ignore it because they don't really know how to interpret what it might be for. More recent theories, though, would suggest that the anterior insular is important for representing salience, perhaps also for representing things that are surprising in your environment. So at the very least, the insular cortex is involved in sort of engaging with the external world in some way. So this is data from our lab, and this is again work with Colleen Merrifield. We replicated this study with Yulia Isachescu, and I put that on PsycArchive. Tried to get it published, but decided that it was just easier to put it out there for the public to see. Where we conducted what's known as a resting state scan. That is an 8-minute scan where people do nothing but look at a fixation cross, which one might expect to be pretty boring. But our intention here was to do this task so that we could get a robust picture of the default mode network. And in fact, that's what we found. So you're looking at activity in the posterior cingulate and precuneus, in the bilateral inferior parietal cortex, and just a hint there in the medial prefrontal cortex. The nodes that you would expect to see in the default mode when you're not engaged with any external task. And then we had people watch a 2 and a bit minute video on loop for 8 minutes of these 2 guys hanging laundry. So not only was it the laundry video, but it was on loop. And again, you see the default mode activated. So posterior cingulate, precuneus, medial prefrontal, inferior parietal cortex bilaterally. The interesting thing about seeing the default mode network activated in this instance is that there is something external to engage with. There's a movie to watch. Sure, it's a really bad movie intentionally, but there's something there for you to watch. And even though there's something there for you to watch, it's so boring, it's so unstimulating that you activate the default mode network. We also had a sustained attention task. I'm going to skip through that. That too was considered quite boring and activated the default mode network. And then we tried to cheer our participants up. We showed them the BBC Blue Planet. And you see now down-regulation of the default mode network as they're engaged in watching this interesting video. If that was all we found from that work, it would be a little bit disappointing, because all you're saying essentially is that a resting state is a boring scan, and when you're bored, you activate this default mode network. But then we looked in at the anterior insular cortex, and during our resting state scan, there was nothing happening in the insular cortex, no upregulation or downregulation of this part of the brain, indicated by the white arrow there. But when you were watching the boring video, there was downregulation of the insular cortex. This part of the brain that I'm going to claim is important for engaging with whatever it is you're doing right now was clearly not activated when you were watching these two guys hang laundry. We saw the same thing, but to a somewhat lesser extent in the sustained attention task. And then when you look at people watching the BBC movie of Blue Planet, you clearly see upregulation of the insular cortex, because now they're watching an interesting movie. There's a lot more to do here in functional neuroimaging that we're going to follow up on, in particular to try and understand the dynamics of the experience of boredom as it unfolds. And we didn't really have enough subjects here or enough spread of trait boredom proneness measures to look at whether or not this differs as a function of trait boredom proneness. So that will be something that we'll sort of follow up in the future. So I'm sort of wrapping it up now. And this picture of Leo here, he looks a little bit bored himself. But the quote comes from Anna Karenina. And I think it's a fantastic quote for encapsulating the way I think about boredom, that boredom is the desire for desires. It's a want. It's a motivational state. It's a wanting state. But you don't know what you want. Or if you are provided with opportunities for things that you could engage with, none of them seem like they're going to satisfy. None of them seem like they're going to work. And so for the highly boredom prone, there's an enormous sort of challenge in launching into an action if you're in that state where you just feel like nothing you could do would actually fit or work for you. And I'll leave you with one last data set to look at. And this is something that we're pursuing now. This comes from mass testing. This is, again, just one sample. This relationship is replicated time and time again in those mass testing samples. And it's a relationship between boredom proneness and self-esteem. And this has been pointed out by my graduate student, Andrew, for a number of years now. And I think he would sort of suggest that many of the relationships that we see between boredom proneness and other factors, like depression, like anxiety, like aggression, may well be fully mediated, or at least partially mediated, by self-esteem. And I point that out in the context of a paper from the late 1950s by Robert White that talks about affectance motivation. And what he means by affectance motivation is that humans, and he would claim animals, and I think I'd agree with him, have a drive to act upon the world and to see that their actions have effects, have consequences. So that when I do something, it changes the world in this way. And White would claim that early life success in that drive for affectance, so early successes in affectance motivation, will bolster self-esteem. And I've talked to you about the fact that boredom is a call to action, that high boredom prone people fail to launch into action. And it may well be that one of the prominent reasons that they fail to do so is because they lack the self-esteem to believe that any of their actions will have the intended effects that they want. That's highly speculative, but something that we're interested in following up. So what's on the horizon for my students and I? This might be interesting for them to learn. So as I've said to you, I'm really interested in the dynamics of this, right? I want to know how boredom as a state evolves over time and how this might play out differently in individuals who are high and low in boredom proneness. And we might find ways to do this in fMRI. We're interested in pursuing the psychophysics again to look at things like heart rate variability, which sort of counterintuitively, high heart rate variability has been associated with better self-control. And so we might expect the high boredom prone guys to have low heart rate variability. We have some EEG data from Tina Willoughby that we're also sort of thinking that we would like to replicate in adults in our own lab to look at power in the various sort of spectra like alpha and theta to see whether or not those can differentiate the high and low boredom prone individuals, and continuing to use our self-report measures to try and understand those dynamics. There's a lot of replications that we're in the process of doing. I talked to you about the genetics work, and that's in need of being replicated, although some of that work is now published already in PNAS, which we're really excited about. The work that I presented to you on effort and other factors that we're interested in, so a notion of a sense of autonomy, a sense of skill, challenge, fit, these are things that we want to pursue further and replicate. And then one of the things just on the bottom there that we haven't actually done anything about yet, but that I think really we ought to. One of the ground zero findings in the boredom literature is that it's strongly associated with depression. This comes from the earliest paper of Farmer and Sundberg in '86 when they developed the scale that most people use to measure boredom proneness. Right there's a strong association between boredom and depression. It ranges from anywhere between 0.5 and 0.7 as a correlation in the mass testing samples that we get. It's strong, it's robust, it's reliable. But what comes first? Is boredom a symptom of depression? Or is boredom some sort of sense of prodromal depression? Do you get bored and disengaged from your environment first and then become depressed as that persists? I don't think we have good answers to these kinds of questions, and I think that they would be really important questions and interesting questions to ask. In the spirit of this being an in-house colloquium and then the idea that we would sort of break down silos, there's probably not that many people in the room that remember that sort of hands across America kind of thing, yeah? But anyway, so I think that a lot of the work that I've been really excited about over the last little while has been because I've been able to collaborate with people outside of my area and within my area. The work on regulatory mode is with Abby Scholar, and the work on genetics has been with Abby and Marla Sokolovsky. The thing I joked about when I met Marla in London in 2013, I think it was, and we had the discussion about this study that we were going to do. I came home and I said to my wife, I'm a geneticist. So she, of course, laughed because she knew that that was a lie. I've just started up something with Ian McGregor, and I always love talking to Ian about boredom because we start our conversations disagreeing. It's like, no, I don't think that's what boredom is. No, I don't think that's what boredom is. And then about half an hour later, it's like, yeah, I think I agree with you. So somehow we sort of get on the same page. But I think there is a sort of different way of conceptualizing things that Ian's very interested in, sort of avoidance motivation and how that plays into boredom. And just now with Jatisha, my graduate student, we've sent out some survey data to patients in our neurological patient database to look at the consequence of left and right frontal injury for the presence of boredom proneness. And there's good reasons to look in that part of the brain. I'm really excited to see how that comes about. Dan, who left the room early because he got bored, he and I have done this work looking at boredom and restlessness that I presented to you earlier. But he's really interested in sort of the association between boredom and mind wandering. We're also following up with my graduate students, Alison and Austin. The cognitive tasks that we use in cognitive psychology are magnificent boredom inducers. Does that influence the behaviours that we then want to go and measure? And I suspect the answer might be yes, but we don't know. The two less than hirsute guys on the bottom row there are potential collaborations. Evan and I were just talking the other day about effort and effort regulation. He's got some great ideas that I think would be really fantastic for us to sort of pursue. I had a conversation with Ori. I've presented you some of that developmental data, but we're missing a chunk of kids younger than 8 years of age. And he and I went for a coffee quite a long while ago, and in the instant, as is Ori's quick mind, he came up with this fantastic task to look at whether or not children present with these different regulatory modes of locomotion and assessment. We haven't brought it to fruition yet, but I'm really hoping that we do. So I think actually, as far as things go in this department, we're pretty good at breaking down some of these sort of silos, but it never hurts to sort of try more. And the last thing I'd say about this slide is, who's with me? Does Ori look like he sort of belongs as a character in Peaky Blinders or something? These are all of the collaborators and students that were involved in the work that I presented, and thanks for listening.
So with that, the GIF of the guy knocking the garbage can over, you suggested they were probably not satisfied with the moment of their current experience. And I was just wondering if you've done research or anyone else has looked at, how mindfulness or meditation affects boredom, because you could argue that a lot of meditative practices are kind of predicated on this idea that the present moment is actually perfect, or that it's satisfying.
There's a lot of work on mindfulness and mindfulness training and potential benefits of mindfulness training. I think a lot of that work is quite dodgy in terms of its design. None that I know of that's looked directly at whether or not mindfulness could treat boredom. But I would suggest to you, and when I've thought about this a bit, we haven't done anything, thought about this a bit, particularly with respect to traumatic brain injury patients. You've got a person with a neurological injury that makes it difficult for them to attend and difficult for them to impulse control, and you want to train them up in a task that needs strong attention and strong impulse control. You're setting them up for failure to try and get them to do the very thing that they've got the biggest deficit in currently, right? So I'm not sure that mindfulness would necessarily work as a treatment of boredom. And I'm not sure that that's really addressing your question, because you sort of seem to be saying, is it the opposite? You know, if I'm in a mindful state, am I happy with that perfect moment? The only other thing I'd sort of say about it, and I don't practice mindfulness, you'll be shocked to learn, I know that Andrew has engaged, I'm not talking out of school to sort of suggest that he's engaged in meditative sort of processes. It takes work. It takes a fair bit of training. So I think if you were to use that as something to try and overcome people's boredom, you'd have to say you're going to be doing this for weeks, maybe months, before you sort of get there. Here's a counterintuitive notion for you. I think that one way that you could help people overcome boredom is to teach them to fidget. And I'm serious that this is entirely a possibility. So if you've ever seen, people might not be that familiar with it, and I can say this now because he left the room early, but if you're ever in our brown bag and you look over at Dan Smillick, Dan's legs are going like this, you know? And if you ask Dan, do you ever get bored? He says, no, never get bored. Never bored. Yeah. But the reason why, it's not just that sort of anecdote that I said, the reason why I would suggest that that might work is because it is imbuing you with a sense of action. You're doing something, right? And so you can feel like that outlet, that desire, that need is satisfied, even though it's perhaps aimless, right? Yeah, Ori.
So this question actually kind of follows up on the last thing you said. So you talked a lot about boredom proneness, but then there's like the rest of us who are maybe not, or like many of us who are not necessarily boredom prone, but of course, if we're like stuck on a very long flight, you know, there's only so much you can do, right?
Yep.
So the question is, and maybe the answer is somewhere in the talk. What does boredom in the boredom prone look different than boredom in the rest of us? The actual state of boredom.
Right. So I suspect that the answer to that is no, that the state doesn't. So the way in which I'm conceptualizing the state is that it's a self-regulatory signal. It's neither good nor bad, right? It's an in-the-moment thing saying that what you're doing in the moment isn't sort of working. Now, you might be like Dan, one of these people who says, I never get bored. Is that a claim that you would make? You're borderline. I just do a name drop here for you. Now, I was having a conversation with Chris Hadfield the other day. I actually contacted Chris Hadfield because he's associated with the university to ask about the experience of boredom in constrained environments, right? And he claims never get bored, never ever been bored, right? And then the conversation goes on and he starts to tell me a story about his life growing up on a farm in Ontario. And he says he used to do the ploughing of the fields for his dad. And he said he loved that because you're ploughing the field, in front of you is field, behind you is ploughed dirt, you're seeing progress, right? Which is a key factor in flow as well. So, and he said, but I hated harrowing. And I said, well, what the hell is harrowing? I don't know what harrowing is. Harrowing is driving your tractor through an already ploughed field to take big chunks of dirt and make them into smaller chunks of dirt. So you've got brown ahead of you and you've got brown behind you and you can't see your progress. So what did he do? He challenged himself to see how long he could hold his breath. Now I put it to you, he was bored, right? But in that moment, he didn't linger on the state of boredom. He didn't linger on the feeling. He just decided that, and he talks about it himself. He sort of says, you know, you have to use 30% of your brain when you're doing most things, so you just do something else while you're doing it, right? So I think that people who don't experience boredom much, rapidly and mostly adaptively respond. They experience the signal, they experience it the same way that you and I do, but they respond to it rapidly. I don't have any data to back that up. That's just supposition. Yeah, James.
I found the call to action really interesting way of thinking about it. And it speaks to what you just said, because it seems like someone like Dan or Ori probably goes and learns something, and that's why they're not bored, right?
Right.
And that kind of speaks to the self-esteem thing, too, potentially. Maybe you have high self-esteem because you know how to do a lot of stuff.
Right.
Right, and that goes together. So I was just wondering, in your foraging data, there was a little bit above my pay grade with the genetics, but...
It's above mine too.
Did you have... I'm not sure I'm interpreting your data correctly, but are the boredom prone exploring more? Or can you say, are they Because I conceptualize learning as almost like an explorer.
So at this stage, the associations between the genetics and boredom are really basically on the self-report sort of stuff. The association between regulatory mode, assessment and locomotion did show differences in behaviour, right? So the assessors tend to hug the boundary, the locomotors not so much. We also found differences, so in a different foraging environment where the berries were distributed in a patchy way, the assessors tended to pick smaller sized berries than did the locomotors. And they also tended to stop to pick berries when there were fewer berries visible. And we couch that as they don't want to let any of the resources go. They want to make sure that they just collect everything that's there and that's available to them. So there are some metrics on that task that do associate with regulatory mode. But as yet, not any great metrics that correlate with boredom proneness, which would be nice if we could find a task that would. And we're in the process of doing that. We're looking at sort of risk-taking tasks, executive function tasks, so sort of go, no-go, self-control sort of tasks that we hope will pull apart the performance of high and low boredom-prone individuals. Yeah, Heather?
In your work with Tina, with the kids as young as 8,
Yeah.
how are you assessing boredom there? Is it
Yeah, so-
measure you use with that?
Yeah, no, so I mean, this was this wonderful data set dumped in my lap, but I had no hand in designing it, right? So she'd already sort of put it through. It's survey data, and she's got massive amounts of it, and we pulled out 3 questions. Are you bored in school? Are you bored at home? And I think the question is, I have trouble getting interested in things. That's the sort of 3 questions. And they were embedded in a range of other sorts of things. And there are other questions in there that we can also sort of pull out that tap into self-esteem, but it's not structured in the way of, I've got this questionnaire from the literature, plonk that in. I've got this question. She's actually just driven it from her own sort of intuitions about what she's interested in, I think. And it's quite extensive.
Because you brought up at that point the idea of contextual constraints.
Right.
In kids' environments that almost don't let them be bored, right? I mean, they're in school.
Right.
Other people are telling them all the time what to do.
Right.
Right? So I imagine that, I was surprised too, that your line really wasn't much
No.
positive slope, but probably if there was a more sensitive assessment of boredom
Yeah.
within a specific activity or behavioral
Yeah.
assessment, I imagine you'd get steeper.
I think you're probably right, but we're sort of out of luck on that front because it's longitudinally set up. She's not going to change that one.
But will those data allow you to, given the constraints on it, your final question about chicken and egg, is she assessing
Mood.
boredom and mood at each age of assessment?
I believe she is. Yeah, Andrew, can you speak to that? Are there questions of depression in there?
Across a number of ages, and we're getting another sample that's
No. So yeah, but are there measures of mood in there? I think there are.
at the moment, I'm not sure.
Oh, you don't
And
think
it's
so? Okay.
longitudinal, it's not cross-sectional?
No, it is. So this is just a snapshot that I showed you today, but it will be longitudinal. Yes.
Right, so then the chicken and the egg
Yes.
would be a great first.
It would be fantastic to look at. Yeah. Yeah, Igor.
I need to cough with you. This is fast. I was doing this the whole time, but at the same time I wrote more questions than I've ever written in a talk before. So this is cool. So I have 2 questions, maybe challenging, maybe not. So the genetic data, the proneness to boredom data versus the state-specific data seems to be talking about state versus trait.
Mm.
And it would be, possibly an ecological fallacy to assume that those processes should theoretically go the same way.
Mm.
Do you see observations of them going in different directions, or are they always consistent?
The more common thing that I've seen in some of the studies that we've done is that whatever metric that we're interested in, whether or not it's something like efficiency of performance on a sustained attention task or some other kind of metric that we're interested in, can be explained in part by the trait of boredom proneness, but that state levels don't tend to explain much of the variance in those performance metrics, right? And the way I interpret that is that if I have the right kind of induction to make you feel bored, I can make everybody in this room feel pretty much equally bored, right? But what is key about the trait is that you just experience it more frequently and more intensely. And we didn't know that, so we added 2 questions into mass testing. How frequently do you experience boredom? How intensely do you feel it? Related that to the scale that everybody's been using to measure trait boredom proneness. And indeed, frequency more so than intensity correlates very highly with boredom proneness. There is work from John Eastwood's group that shows that that state and trait boredom do go in the same direction with respect to errors on sustained attention tasks. But actually in that paper, he also showed that over and above state ratings of boredom, trait boredom proneness predicts errors of attention. So it seems that something fundamentally about the person is more important than the state itself in terms of driving the associations that we're looking at.
Just a quick follow-up there. Any diary data on boredom?
I don't have any. I think there's some in the education. I think there's a little bit in the education literature. Jatisha, you know something about that. But so I don't know if you've got anything to say about it. But
Heckford and Gullet were the two researchers that do diary data, and they kind of follow students. They look specifically at achievement settings in math and physics particularly, and they try to investigate how much control would lead to boredom within those settings, or how much challenge skill set would lead to boredom within those specific settings. So they would track and they would get people to.
I don't think they get sort of every week though. They sort of get them once a term and follow them before exams and after exams. The association that you make with math there makes me think there's one paper of 9-year-olds and boredom, and they try and look at academic achievement and boredom in these 9-year-olds. And it's a very small sample, so I wouldn't put a whole hell of a lot of stock in it. But math ability did not correlate with boredom proneness at all. Reading did. And their assumption was that if you read more, you had a greater capacity for imagination, and so you'd be less bored. Yeah, there we go. Daniela, I'll come back to you.
Not so much a chicken and egg question, but related to depression. I wonder if it might be important from a mental health perspective and recovery perspective to know a person's initial sort of proneness to boredom, and then when life adverse events might lead to a state of monotony.
Right.
Then, some people may be actually able to withstand that monotony better because they were more prone, or less prone to boredom.
Yeah.
Or whichever.
Yeah.
Anyway, they boredom doesn't bother them as much.
Yeah.
But others who are more usually can act on it quickly and now are not able to. And
Right.
it could be very different, and they could sink into a much deeper.
Yeah. So it feels a little bit like your question's coming from sort of thinking about later stages of life too. And I think there are huge sort of associations to be had between boredom and loneliness and social connectedness at that end of our sort of spectrum. And so there, I mean, the sort of question that Igor asks about, are these things the same or not? Is the state and trait the same? I wonder whether or not the state is different across the lifespan, but maybe sort of stable within individuals.
I'm also thinking of like mid or late, where it's something, you would normally be active and everything.
Yeah.
But maybe
But then it's prevented from.
Or something that you've got to deal with. So, and then later in life, loneliness, or for women, you've outlived everybody, so your social network's not there anymore. Whatever, could be going on.
So I only have sort of an anecdotal thing to say about that because I don't know of any data that would speak directly to that. But certainly mental health issues tend to rise in elite athletes when they retire, right? And that sort of fits with the notion that you're sort of talking about, that they've operated at this very high level of effectiveness, being very good at what they do physically. They stop doing it, and now they're prone to problems with mental health. But beyond that, I mean, I don't know anything else. Yeah, Richard.
It's really fascinating work, and nice integration of evidence. One thing that I'm curious about, though, is to what extent do you think many of your predictors of boredom proneness might also be predictors of successful regulation of any negative aversive state, like distinctly bored,
Yeah.
and what's not?
Yeah, and so with all of these common associations we have between boredom and depression and anxiety and increased levels of aggression, there's right, and so that would be a great one to sort of measure. I think that the very short and quick answer is there's almost certainly just an underlying mechanism here of dysfunctional self-regulation, right? And that it pans out as, and so I've started from boredom, and I couch the work in those terms, and I'm very interested in that sort of thing. But I don't think I could stand here and seriously mount a case that there's something unique about the self-regulatory challenges of someone who's high in boredom proneness versus someone who's. It might just be that the surface presentations of them look different, but I don't know for sure. Yeah, Evan.
Related to Richard's question, but maybe more specific. Is there any negative attribute that high boredom prone people wouldn't identify with?
So my gut reaction to that was there's an association between psychopathy and boredom proneness. So if they're going to associate with that, then perhaps the answer to your question is no. I'd have to give that a little bit more thought, actually, as to whether or not the answer would just be no, that if you're high in boredom proneness, that there's just nothing good associated with that. And so I could choose any kind of domain of sort of negative functional outcome, and the highly boredom-prone person might endorse it. It's entirely possible, maybe I shouldn't really be spending too much time trying to find that one thing that they that they don't associate with, if indeed it is just a generalised problem of self-regulation, right? So I don't know. It's a good question. I think Myra first, and then.
Quick question. In the Drosophila data and in the human data, particularly with respect to locomotion, were there sex differences? Because especially with the developmental profiles, young little boys versus girls might have different patterns. So did that come out in any food fly or human data?
Yeah, so it's a great question, and we looked because I was expecting that there would be. So if you go through the literature, even that study that I mentioned about the 9-year-olds, very small sort of sample, one of the more consistent findings is that men tend to be higher in boredom proneness than do women, right from that age of 9, right? So you might have expected there to be some difference in that data set, and there just wasn't. We had even numbers of males and females in that sample, and sex had no effect. So I was a bit disappointed in that, but that's the way it was. And I should say that the effects of gender and age on boredom proneness as predictors doesn't account for a huge amount of the variance, right? So things like self-control and self-esteem account for far more than do age or gender or sex. Colin.
Is there any evidence that people self-select what they do on the basis of their boredom proneness? Like, are air traffic controllers more less?
I hope that air traffic controllers are less boredom prone rather than more boredom prone. Because this is one of the applied places that you might sort of try and work your understanding of this in educational settings, jobs that have high rates of monotony but high rates of serious consequences if you fail in that sort of task. And air traffic control is one that I use fairly often. So you'd hope that those guys can cope with monotony quite well.
Can you learn anything from, is there anything they do to accommodate that?
Yeah, I don't know. I'm not sure.
Other than, say, fidget and hold their breath?
Yeah, I don't know. So it's an interesting question that I think would be worth doing, and perhaps one that you could do on Mechanical Turk. Just try and get as many different professions as you could, and see whether or not profession actually determined these things or not. Be well worth doing. Yeah, Marla.
Just trying to think about. I don't know if you're familiar with Tom Boyce's orchid dandelion hypothesis for children. He has a book coming out, How to Raise an Orchid Kid.
Is this sort of like the nurse warrior kind of
The orchid
a
children
warrior
have
sort of
very high sensitivity to context.
right?
And so they're what you're calling biophysical characteristics like response to touch or pain or cortisol or heartbeat. They're just more responsive.
Okay.
And the dandelions are less so.
Right.
And depending on the environment they grow up in.
Yeah.
The orchids can do really well if they're watered and humidified, and very poorly if they come from a more adverse environment. And in a sense, the dandelions are more buffered to this.
Right.
So I'm wondering, and there's been a lot of genetics done on that and gene-environment interaction. I'm
Right.
wondering about sensitivity of
Yeah.
more boredom-prone people.
So I don't have anything directly that I think would speak to that, with the exception perhaps of the self-esteem as potentially a buffering sort of factor, right? But then, as you point out, when you outline that distinction, environment's going to play a huge role as well. And we haven't really, in all of the sort of survey data that we've collected, we haven't really sort of tried to extract out environment factors, things like what Danielle is bringing up in terms of adverse life events as well, and early adverse life events versus later and this kind of stuff. I think all of that would be very interesting in trying to understand the profile of this sort of dysregulatory individuals. But I don't have any data on it yet.
Second question.
Yeah.
In terms of what you said about the math and the reading
Yeah.
and math ability, so it'd be interesting to do perceived math ability.
Oh yeah.
Because that's for females and males. It's the perceived math ability that's different for women. For girls, it's lower
Right.
than the actual math ability. And then to do the same thing for reading.
Right.
And then bring the boredom into it if it's part of a self-esteem thing as well.
Right. We have done some work with Dan looking at the association between boredom and mind wandering. And there's a sort of positive association between boredom and mind wandering, both the distinction that he and others will make between sort of spontaneous and deliberate mind wandering. Now, the spontaneous is where your mind wanders off task when you don't want it to, and it's sort of seen as a bit of an intrusive kind of thing. And that relationship is significantly stronger than the relationship between deliberate mind wandering and boredom. And I suspect that the deliberate mind wandering might be a sort of coping mechanism that then you could sort of churn back to this notion of an association between perceived ability at reading or perceived capacity. You know, when you read a novel, do you imbue the characters with voices in your head or not, right? And how much imagination and creativity do you put into it? And does that sort of thing play into your resilience to boredom or monotony? I think those would be great questions. Yeah, Ian. No, I disagree.
Yeah, one of the favorite things I like to disagree with you about is the order of self-control of boredom.
Right.
And it seems your best evidence that it goes self-control of boredom is the brain injury stuff, right? That's
right.
The strongest evidence you have. Like, I'm not thinking of that. I thought maybe I can still disagree with you because, like, is it possible that the bored people are doing risky things?
Yeah, no, with the brain injury sort of stuff, you're always stuck with that, right? Because you want some sort of measure prior to their injury. Were they high risk takers? Were they? Yeah, that's right. And so I don't have any data on that, and I don't think anybody does. And that's a perennial sort of question. And unless you could, of anybody doing work with traumatic brain injuries of this kind, is you want pre-data, you want baseline data, and no one ever has it. So unless you could sort of, do one of these kind of survey things that they do a lot of in the United States, where I just take 100,000 people and I do all this, and then I just track them and I get the 5% that have head injuries and follow them afterwards, right? I don't know how else you could do that sort of study. But having said that, I actually think I'd agree with you. That I think the people most prone to getting traumatic brain injuries probably are the risk takers that have low levels of self-control as well. But that doesn't mean that the brain injury hasn't exacerbated that post anyway. And that's actually one of the classic things that people say about traumatic brain injury, that you don't get sort of distortions of who they were pre and post, you get exacerbations of who they were. So I think there's one question at the back there.
So the last question. My question is, if we accept the framework of boredom as a call to action,
yeah.
Or the desire of desires, but then you pose the solution, or a potential solution to something like fidgeting, or say holding your breath, or I would even extend that to like social media or recreational drug use. Those, I think, are things that satiate the feeling or the need, but don't necessarily provide a medium to give you what you're looking for, which is desire. So are they maladaptive in the long run?
Yes. So Mike does work with problem gamblers, so getting into this state that he sort of calls dark flow, right? So they're sitting there on the poker machines, whatever they can call these bloody things, and they're in the zone, right? But that there's a great feeling of sort of shame, guilt, dissatisfaction, negative emotional states when you finish that and when you're done. And there's some data to suggest the same thing is true when you get off social media. So you are engaged when you're on social media and you're not bored. I will buy that. But it's not adaptive engagement. And the more you do it, and the more you do it in problematic ways, and so this has been characterized as people who demonstrate cravings for social media when they're off it, the more you do these kinds of, the more you adopt these kinds of means of engagement to deal with boredom that are maladaptive, it'll be a vicious cycle. You'll get off it, you'll be unsatisfied, you'll turn to it, you'll get off it, you'll be unsatisfied, you'll turn to it. So I do think that there are adaptive and maladaptive ways to respond to being bored. And social media is one of the, I would suggest to you, maladaptive ways.
All right. So we'll close this session for now, and we'll continue upstairs in less than 10 minutes, where we'll also be doing the awards, as well as we'll have some drinks. So James,
I'm all for that.
Relax a little bit. Thank you so much, James.